Hello everyone. Myself Dr. Yogita Mahatekar. I am as an assistant professor in COP Technological University. In this lecture, we will be studying Chi-Square distribution and its basic properties and definition. Chi-Square distribution is a very important sampling distribution, and in this lecture, I'll assume that the audience knows some basics from probability theory, probability distributions, binomial Poisson and normal distribution, and normal distribution. Let me share my screen. I hope it's visible to audience. So I have already introduced you myself. Now we'll look at this definition of Chi-Square distribution. So Chi-Square distribution is defined as the sum of squares of standard normal random variable Z. So Z is a notation for standard normal random variable. Z is x minus mu by sigma, where mu is the average of standard normal random variable Z. Sigma is the standard deviation of Z, where x is normal random variable, not necessarily standard one. So how chi-square is defined? Chi-square random variable is the sum of squares of standard normal random variables Z1, Z2 and Z up to Zn. So if you add n standard normal random variables, then will form a chi-square distribution with n degrees of freedom. I mean, suppose I add 4 standard normal random variables and their squares, it will be a chi-square distribution with 4 degrees of freedom. Go to the next page. Now, chi-square distribution is not a symmetric distribution, which we can check using the probability density function of this distribution, but for the time being, we will skip probability density function of chi-square. Next, chi-square distribution takes only positive values. So chi-square distribution shape is a bell-shaped curve, but it is not a symmetric curve, and its graph lies above horizontal axis, so it means that its value is greater or equal to 0. Now let's go towards this theorem. What this theorem says is, if you consider two independent random variables, chi-square m and chi-square n, which are having m and n degrees of freedom, then the addition of these two random variables will give rise to a new standard normal random variable, which is again chi-square distributed with m plus n degrees of freedom, which is quite natural. Next is this particular equation 8.25, which is very important. Now all of you know that S square is a standard notation for the sample variance, and it's a random variable. Why it is a random variable? Because sample variance will change from sample to sample. So if you multiply by n minus 1 to the sample variance S square, and if you divide by the population variance sigma square, it will give rise to a chi-square distribution with 1 degree less than n, I mean n minus 1 degrees of freedom. The next page will solve some examples on chi-square distribution. The first one is using statistical tables, you have to find out chi-square 0.025 when the degree of freedom is given to be 50. So let's concentrate on this first question. For that, you will need the statistical tables. So let me just open the statistical table for the chi-square distribution. Now there are two pages regarding chi-square distribution statistical tables. The first one is containing the graph of chi-square distribution. If you see, on the horizontal axis you have this notation chi-square alpha, and the right hand side part of this value chi-square alpha is shaded with the blue color. And what's the suffix? Suffix is alpha, and alpha is the shaded region. So this is the probability density function curve of chi-square distribution, which is not symmetric, but it's bell-shaped, non-symmetric bell-shaped curve. And right-hand side area is alpha. I mean, it is a stage after which your area is equal to alpha. Okay. So now we are interested in chi-square suffix 0.025. So what does it mean? It means that this right-hand side area we are interested in has to be 0.025, and therefore the question is, what is that stage after which your area under the PDF of chi-square distribution is 0.025? Okay, so for 15 degrees of freedom, we'll search for. So let me just scroll this page down because we have to find the 15 degrees of freedom, and for alpha is 0.025. So this first row is alpha values, namely probability values, and this nu in the first column denotes the degrees of freedom. So in this case, we will go down and we will form for 15 degrees of freedom. So let me just highlight this row for 15 degrees of freedom. Nu denotes 15 degrees of freedom in the table, and for alpha is equal to 0.025. So what's the intersection? Is 27.488. So what does it mean? For a 27.488 value of chi-square, area after that value is 0.025. Similar is the case with the second question. Chi-square 0.01, when degree of freedom is 18, you have to find. So let's again go to the same table. For 18 degrees of freedom, let me just highlight this row, and for 0.01 it is 34.805 is the value of intersection. So in the graph of chi-square distribution, after 34.805, your right hand side area is 0.01 for 18 degrees of freedom. So this is how to make use of chi-square tables, and one more example we'll take. Now suppose I have to find out the probability that the sample size of 28 is taken from the normal population with the variance 4. So normal population is given with the variance 4. I mean chi-square, which is denoting the population variance, is equal to 4, and your sample size is 28. And you have to find the probability that sample variance will be greater than 6.1. Sample variance is denoted by S square. So probability that S square is greater than 6.1 is probability n minus 1 into S square by sigma square is greater than 27. 27 is n minus 1 into 6.1 by 4. So what I'm doing over here, I'm multiplying by n minus 1 and dividing by sigma square. So you know n minus 1 into S square by sigma square follows chi-square distribution with 1 degree less than n, that is 27 degrees of freedom, greater than the multiplication and addition. This gives rise to this calculation is 41.175. Now you have to find out the probability that chi-square for 27 degrees of freedom, 41.175. So again go to a table and you have to find, let me just clean my page, otherwise it will go for the next page also. So you have to, what you have to do is for 27 degrees of freedom, you have to find out the probability that chi-square is greater than 41.175. So let me go to the next page. For 41.175, so that is on the next page we'll go for. So all of you just look at this row. So here, these are the two values. In between these two values, 41.175 lies. So what you do is you just go up and you have to find out the corresponding alpha value. So 41.175 lies in between, for 27 degree of freedom, of course, it lies in between 40.113 and 43.195. So the corresponding value of alpha we will check for. The corresponding values of alpha are 0.05 and 0.025, isn't it? So this is 0.05 and 0.025. So the average of 0.05 and 0.025 is, we will be taking it as 41 lies in between these two values. So 0.05 and 0.025, their average is 0.035. So this is how to make use of statistical tables to solve the mechanical examples on chi-square distribution. In continuation with this lecture, in the next lecture, we will be having the applications of chi-square distribution, namely chi-square test in testing of hypothesis after the series of lectures. So with this, I will stop over here and we will meet in the next series of lecture. Thank you.